All right, so looking at number one, this is it says solve, and what we have here is what we call a radical equation. We have an equation that has a square root in it. And if we recall the method used in solving this kind of equation is we first look, is there anything outside of the radical? And the radical is all by itself, the radical is isolated. So then I look at the number that's on the other side. I make sure it's positive, because if this would have been a negative number, I would have known right then and there, there's no solution. You can't solve that kind of a question, but it's a positive number. So then we go to our method of squaring both sides. As long as we do the exact same thing to both sides of an equation, we maintain our equation. Now, when we square or multiply the square root of 2r minus 5 by itself, it gives us the 2r minus 5, because anything in a square root, when it's multiplied by itself, is going to give you what's in that radical. The other side of the equation is not in a radical, so I actually have to multiply by itself. So I have to do 25 times 5. I square the 5, it gives me 25. And now I have a regular equation without any radical. So I just solve it regularly, which gives me 2r equals 30, 25 plus 5. And when I divide both sides by 2, I get my answer is 15. Notice we have to check if that's a good answer, because anytime you have a radical, you have to check the answer. So if I'm checking the answer, I'm doing 2 times 15, which is 30, minus 5 in the square root, which is the square root of 25. And that does indeed equal 5. It checks. So my answer is choice C. See what everybody put on the, so choice C is the correct answer. I see those, and that's what everybody seems to have picked. Great. I see you picked, did that also. Okay, so now let's look at example number 2. Example number 2 and example number 3 are both examples that are using that special number I. Remember, I stands for the square root of -1. It's what we call the imaginary number. And we know that when we're working with i's, we do exactly what we would do with regular algebra. In other words, if I want to multiply 9 minus 2i times 4 minus 9i, those are two binomials I have to use FOIL. So I'm going to do 9 times 4, and that's going to give me 36. Then I'm going to do outer 9 times -9i, which is minus 81i. Inner negative 2i times 4, which is negative 8i. And last, negative 2i times negative 9i gives me positive 18i squared. And what you have to remember is that wherever you see an I squared, this is where it's different than regular algebra. I is a specific number. It's not a variable. I squared is the square root of -1 times the square root of -1, which is just -1. So whenever you come across an I squared, I replace it with -1. So this will give me 18 times -1, which is -18. So now I can combine the 36 minus the 18, which will give me 18. And the negative 81i minus the 8i gives me negative 89i. And that happens to be choice C. This one is also choice C. When I looked at the answers, I knew right away B couldn't be the correct answer because you never leave an answer with an I squared in it. Actually, it's the right numbers, but it's not simplified, and we'd have to simplify. Whenever you come across an I squared, you have to simplify it to -1. Okay, question number 3 is 3 plus I divided by 2 minus 2I. This question was multiplying what we call complex numbers, numbers that have i's with them in them. This is dividing complex numbers. And we're really not doing a division. What we're doing is a simplifying by trying to get rid of the I that's in the denominator. Now, when your denominator consists of 2 terms, it's not just, let's say, 2i. That I could have just multiplied top and bottom by I. But this is 2 minus 2i. What I have to multiply by is what we call the conjugate of the denominator. So 2 minus 2i conjugate is 2 plus 2i. It's the exact binomial except with the opposite sign. And whatever I do to the denominator, I do the exact same thing to the numerator. So I'm multiplying by 2 plus 2i over 2 plus 2i. Literally, I'm just multiplying by 1, so I'm not changing the value. Now, if you recall, I always like to do the bottom first. That's always going to be easier. And I like to see the i's, get rid of the i's. Why is it easier? Because when you're multiplying conjugate binomials, the outer and inner terms of the binomials will always cancel out. So you really don't have to do the whole 4. You could just do first 2 times 2, which is 4. And last, negative 2i times positive 2i, which is negative 4i squared. That is your denominator. And of course, wherever I have an I squared, I've got to replace it with a -1. So this becomes 4 plus 4. So it comes out to be 8. My denominator is 8. Let's see what happens to the numerator. The numerator are just 2 binomials. I have to actually do the complete FOIL. First, 3 times 2 is 6. Outer is 3 times 2i, which is 6i. Inner, I times 2, which is 2i. And last, I times 2i, which is 2i squared. And again, there's our I squared, so I have to replace the I squared with -1. So what I'm getting here is, this is a 6. This is 2 times -1, which is -2. So 6 and -2 gives you 4. And 6i plus 2i is 8i. And this is all over 8. But if you notice, it doesn't look like any of these answers, because when we have something in, we want to put it in what's called A plus BI form. Which means what we want to do is take each of these and separate it and put it 4 over 8 plus 8i over 8. That's what's called A plus BI form. Instead of writing it as all over a single number, you separate it and put each number from the top on top of the bottom. And you can reduce this, because 4 over 8 is 1/2. And 8i over 8i, the 8's cancel out, so that's just plain I. And of course, that is choice A. So that requires a little bit of work. Don't forget you multiply by the conjugates. All right, any questions about what's going on here? Okay. So let's go on from here and continue with what we were started talking about on Friday, which was solving quadratic equations, which is something that we're coming back to because we already really solved quadratic equations, except the method that we had did not allow us to solve every single quadratic equation. We had a method where we would factor. We would break our quadratic into two parentheses and then solve each parenthesis separately, which means that you have to be able to factor, and not all trinomials are factorable. So we talked about a method that's called the square root method, where if I give you something like this, x squared, let's say give you 5x squared minus 100 equals 0. This is a quadratic equation because it has an x squared in it, but it's not a complete quadratic equation. It's called an incomplete quadratic equation because usually with a quadratic equation, you have an x squared term, then you have an x, and then you have a number. And here you only have the x squared and the number. When you have that kind of equation, there's a relatively simple method that can be used to solve that quadratic equation. What do? You solve it like it's a regular equation. Think of this as if it's not an x squared, but an x. So of course, the first thing you're going to do is bring the 100 to the other side. And you get 5x squared equals 100. And then, again, if this was a x, you would divide everything by 5. So that you end up with x squared equaling 100 divided by 5, which is 20. And here's your next step. You can't stop here because this is not x, this is x squared. This is where it's called the square root method. What you do is you do plus or minus. Remember this symbol, a little plus over a minus means you're getting two answers. One is the positive number, one is the negative number. The square root of whatever that number is. Notice 20 is not a perfect square. There's no way I could have ever solved this by factoring. Because if you're factoring, you can't get things that come out into with i's or with square roots. This is not factorable, but it is solvable because I know the square root of 20, I can simplify into the square root of 4 and the square root of 5. And of course, the square root of 4 is 2. So my answer comes out to be plus or minus 2 square root of 5. And you could leave your answer like that, or you could write it as two separate answers. 2 square root of 5 is one answer, and negative 2 square root of 5 as your other answer. In other words, you get two answers for your quadratic equation, one being a positive number, one being a negative number. And this is what's called using the square root method to solve a quadratic equation. And the square root method even goes further. What does that mean? what if I didn't have just, suppose I had something like this, x minus 10 squared equals 25. This is not just an x squared, it's a whole binomial squared. But actually, we can use the square root method on this as well, because what we have here is something squared equaling a number. So our next step is to take the square root of this, which is just going to be x minus 10. Anything that's in a square, when you take its square root, you just get what's inside the parentheses. And on the other side, just like we did over here, we went from x squared equals 20 to x equals plus or minus the square root of 20. Over here, we're going to go to x minus 10 equals plus or minus the square root of 25. And of course, we're now going to try and simplify. So the square root of 25 happens to, that's a perfect square. So that comes out to be just 5. In other words, I'm getting x minus 10 equals plus or minus 5. But we are interested not just in what, we don't want what x minus 10 is, we want what x is. So in order to get x alone, what we're going to do is we're going to add 10, just like we would in any equation. And I always try to put the number that I'm adding or subtracting in the front, because that's how they want that's the standard method that's used. So then I'm getting, my answer is 10 plus or minus 5. Well, what does that mean? It means that we have two answers. One answer is 10 plus 5, and the other answer is 10 minus 5. It happens to be that these numbers can be combined because they're just both regular rational numbers. So one answer is going to be 15, and one answer is going to be 5. And here are my two solutions. If I hadn't had that method, I would have had to do a very long method. I would have had to use I would have had to remove the parentheses by doing FOIL on x minus 10 times x minus 10, and then get it equal to 0, and then factor it, and then solve it. This square root method happens to be a very efficient way of solving a quadratic equation. I'm going to do another one, and before I give you one to try. Let's say I had x minus 7 squared equaling negative 81. Okay. Again, we have an expression where we have a binomial squared equaling a number. And I can then, and that's a perfect setup for using the square root method. I have something squared, a parenthesis squared, and it equals a number. Because right away I can take the square root of both sides. Obviously, this side is just going to give me x minus 7. But the other side, I'm actually going to have to do the square root of. It's going to be plus or minus the square root of negative 81. Again, remember the steps. After you have something squared equaling a number, you take the square root of both sides. The side that has a square, when you take its square root, just gives you what's in that parentheses. Just gives you that x minus 7. The other side, you really have to do the square root of. So you do plus, and you have to do a positive answer and a negative answer, because you got to get the two answers. All right. Let's try and simplify the square root of negative 81. Well, if you remember, that really is the square root of 81 times the square root of negative 1. And the square root of 81 we know is 9. And the square root of negative 1, we just learned that, that's I. In other words, x minus 7 equals plus or minus 9i. So, and after we simplify this, then we want to get the x alone by doing plus 7. And remember what I told you, put the number that you're bringing over in the front, not in the back. Though it's not wrong, the better, the way it's mostly done is to put the number that you bring over in the front. These are not going to be you're not going to be able to combine these, because this is a 7, a real number, and this is a 9i, which is an imaginary. Actually, that's why we do it this way, because if you notice, it right away gives us an answer in a plus bi form. The real number comes out in front, and the I part comes in as the second part. And that is your answer. You could leave your answer as 7 plus or minus 9i. Or if you wanted to, we could have written it separately as 7 plus 9i is one answer, and 7 minus 9i is our other answer. So again, you have your choice. Usually I leave it like this, but you have your choice of how to leave it. The 7 plus or minus 9i means you really have two answers, one with a plus and one with a minus. It's just a shorthand to make it easier to less writing involved. Okay, so now I'm going to give you one to try. X plus 3 squared equals 50. And I'm giving you a few minutes to try that one out. While you're doing this, I'm going to be taking attendance. Olivia, Isis,
I'm here.
hi, good morning.
Good morning.
Alvaro, good morning. Lewis Hart. Emma,
I'm here. Good morning.
good morning. Demetrius,
Here.
good morning. Desmond, Shania, Caden, Kayla, Kayla, you there? Sanjita, good morning. Ariana, I know you're here.
Good morning, Professor. Did you say my name?
Who was that?
Naya.
I didn't get to you yet. No, you're at the end, you're at the end of the alphabet. Not yet.
Oh yeah, my last name. Yeah. All right.
Okay. Tahira,
I'm here.
good morning. Michaela. Kiana,
Here.
good morning.
Good morning.
Carleaf. Good morning. Jenna. Tatiana. Good morning. Naya, now I got to you, Anaya.
Hello.
Okay. Kazandu. Trina. Jean. Missing somebody. Okay, Kayla, I guess you didn't hear your name. It's your here. Okay. Okay. Demetrius, I see you gave me an answer. I'm giving you extra credit for that. And let's see if that works. Let's see if we can do this problem. If we're following the pattern, we have something squared equaling a number. So the next thing is just to get rid of the square. So that'll give us x plus 3 on the left side. And on the right side, I always like to write this out, plus or minus the square root of whatever that number is. And the next thing I do is I ask myself, is this a perfect square? Is the square root of 50 a rational number? Now, remember, you're not, I see what you did, Demetrius, but when you take the square root, you're not just dividing it by half. You're looking for a number that multiplies by itself and gives you this number. Well, 50 is not a perfect square. But what we can do is we can simplify it into the square root of 25 and the square root of 2. And the square root of 25 we know is 5. So what we have here is x plus 3 equals 5 equals plus or minus 5 times the square root of 2. I'm replacing the square root of 50 by its simplified version, 5 radical 2. And now I'm going to bring this 3 to the other side because I want it the x by itself. That'll give me x equals, remember, I always take this number that I brought over, that goes first. And then I do the plus or minus 5 radical 2. And I can't go any further. I mean, I could write this as two separate answers. I could write it as -3 plus 5 radical 2 as one answer, and -3 minus 5 radical 2 as the other answer. Or I could just leave it like this. That would be perfectly all right. But we can't combine these because these are not like radicals. This is a real number, a rational number, doesn't have any radical next to it. And this is irrational, it has a square root of 2. Okay. Now I'm going to show you how we can make use of this method even when we're not given the example in this format. We're not given it as something squared. Here's what we can do. This method is the method that's called completing the square. And in order to do this completing the square method, we have to be aware of what a binomial square looks like. So I'm just going to give a couple of binomials and we're going to square them. And we're going to see the pattern involved in that squaring. Let's say I have x minus 5 squared. And I wanted to work this out. I wanted to actually multiply the x minus 5 times the x minus 5. We did this back a couple of chapters ago when we were working with polynomials. We know that when we're squaring a binomial, remember, we're not trying to solve an equation, we're just trying to square a binomial. We know that we have to write it twice and then use FOIL. So we'll get x times x, and that'll give me x squared. Outer will give me -5x. Inner will also give me -5x. It turns out that the inner and the outer are the same because you're multiplying the same thing by itself. And last will be -5 times -5, which is plus 25. And if you notice, well, we can obviously we can combine this to x squared minus 10x plus 25. Now I want to show you the pattern that we're seeing, because if we could do it quicker, that's really great. It's always good to be able to do something accurately, but quickly, because it just gives us that much more time. So let's look at this x minus 5 squared and compare it to what the final answer is when you eventually multiply it out. Now, first of all, I think it should be obvious. When you're multiplying a binomial by itself, you're going to get a trinomial as your answer. That's because the inner and the outer always combine to make a single term. Not only do you get a trinomial, but you can see right away. The first term of your trinomial is going to be the x times the x, or the x squared. The last term of the binomial is going to be -5 times -5, which is positive 25. In other words, the first term of your trinomial is the first term squared. The last term is the last term squared. And what about this middle term, this term in the middle? Look at these two numbers that are in the binomial. If I multiply them together, x times -5, I get -5. But this is not -5. X times -5 is -5x. This is not -5x. This is -10x. Why? Because when we're doing FOIL, we're getting this -5x twice. In other words, if I would have just looked at this, x times -5 and gotten -5x, the middle term would have been double that, -10x. What if I gave you x plus 8 squared? What would we get? Now I'm going to do it the short way, without doing the whole FOIL. I know I'm going to get a trinomial. These are not conjugates. Things are not dropping out. The inner and the outer are the same, so we get a middle term. Our first term will be the x times the x, which is x squared. Our last term will be the 8 times 8, which is 64. And the middle term I get by multiplying these two together, 8 times x, it's positive, and doubling it, so it's plus 16x. There's no trick to this. It's just a matter of seeing the pattern. I'm going to do one more with you, and then I'm going to give you one to try. Suppose I have x plus 12 squared. Again, I want to just expand it into a trinomial. I'm not solving an equation. Just want to expand it into a trinomial. So the first term would be x times x, or x squared. Again, I skipped to the last term. Last term is 12 times 12, which is 144. And the middle term, I multiply these together. 12 times x is 12x, and double it. So it's 24x. Ready to try one on your own? Suppose I ask you to do x minus 4 squared. I'm giving you a few minutes to write the trinomial that's x minus 4 squared. In other words, x minus 4 times x minus. Okay, I think we had enough time. Let's see if we can do this. Following the pattern, the first thing is going to be x times x, which is x squared. I'm going to skip. I'm going to go to the last term. Last term is going to be -4 times -4, which is plus 16. And the middle term is going to be the x times -4, which is -4, double, multiplied by 2, that gives me -8x. Now I'm going to go backwards. Now, what do I mean go backwards? What if I gave you something that looks like this? X squared minus 12x plus 36. And I want to factor this. If I look at it carefully, I'll see that this is a perfect square binomial. Why? Well, the first term is x times x. That's a perfect square. The last term is 6 times 6. So that's a perfect square. And the middle term is actually double what this is. So it must be that this must be x minus 6 squared. It must be x minus 6 times x minus 6. In other words, if I see that the coefficient of the middle number, if I divide it by 2 and square it, it gives me the last number, then I know I have a perfect square binomial. If I have something that looks like this, x squared plus 20x plus 100. Notice what I see. Well, here this is just x times x. Half of this is 10, and 10 times 10 is 100. This is a perfect squared binomial. This is x plus 10 squared. How do I know? Because half of this number is this number squared. Half of 20 is 10. 10 times 10 is 100. That is the pattern. Now, why am I making such a big fuss about this thing? This square? Because it leads us to a method that we can use to solve the quadratic equation called the least square method. There's one more step we have to do before we can actually get to a solution. Suppose I had this, x squared minus 10x. And then there's a plus and there's a blank. I'm only giving you 2 terms of the trinomial. What number would we need to have over here in order for this to be a perfect square? Well, let's remember in other words, we want to get a binomial squared out of this. Well, of course, the x squared will give us just an x. How did we get to this -10? If you remember, we took the 2 numbers, that the x and the number, and doubled it to get to this -10x. In other words, the number over here has to be half of that. It has to be -5. And not only that, the last number, which I didn't give you, you can now figure out, because -5 times -5 is going to give you plus 25. Let me do another one. Suppose I have x squared plus 14x plus blank. Again, I'm giving you two terms of the trinomial. I want it to be a perfect square. Let's remember what the perfect square binomial is going to be. Obviously, the first term is going to be x. But what's the second number going to be? It's always half of this number. Half of -10 was -5. Half of 14 is +7. In order to get my middle term to be 14x, I have to multiply these two and double it. So to undo it, I just divide it by 2. Which means that now I can figure out what my last term is going to be. It's going to be 7 times 7 or 49. So notice I can figure out what number I can add to complete the square to make this a perfect square. That's why it's called completing the square, because it's incomplete. We only have 2 terms and we really need 3. And we can figure out what the number is, and we can also figure out what the binomial squared is. Here, let's see if I give you one to try. Actually, I'll give you 2. So I'm giving you x squared minus 4x plus blank. And it has to be something squared. That's number 1. And suppose I give you x squared. Here's this number 2. X squared plus 12x. Plus, here's our blank. You have to fill in that blank, and we also have to write the binomial. I'll put the x in for you. But you have to do the best. Okay, I'm giving you a couple minutes to try this. See what number you would put inside the parentheses to make this into a perfect square, and what number would have to have been the third number in order for that to be a perfect square. Okay. Doing this first one. I know the first term is going to be x. The second number is -4. So I know what I have to do is divide it by 2. That'll give me -2. And to get the number to add it over here, I have to do this number multiplied by itself. -2 times -2 is +4. The number that you're adding at the end will always be a positive number, because whenever you square a number, whether it's positive or negative, it's going to give you a positive answer. Going to this one, we have x squared plus 12x, so it's going to be x plus, well, we have to take half of the 12, which is 6. So that'll be x plus 6 squared, and the number that would have to have been over here would have been that 6 times 6, which is 36. So here's our perfect square, and here it is in its factored form and written as a binomial squared. Okay. Are there any questions about this before I go on to the next step? Okay, so here is this is really the important part. We need to do all this in order to understand what we're doing now. Suppose I had given you the quadratic equation. I'm going to give you y squared plus 6y plus 5 equals 0. Happens to be on your sheets that I gave you for the term, the week. In section 7, it happens to be question number 8. Okay. We're going to talk about solving a quadratic equation. Now, the first thing I'm going to do is I'm going to solve it our old method. Our old method is to try and factor what we have here. And I think we can factor it. Regular factoring. The y squared is going to be y and y. Remember, we then go, there's no number in front of here, so we can then go to the last term, which is 5. We're looking for two numbers that multiply to 5, and when we add them, they add up to 6. Well, obviously, that has to be 5 and 1. And they both have to be positive because the middle sign is positive. So we factor it, and then we take each parentheses, each factor, and set it individually equal to 0. So we get y plus 5 equals 0, which is -5. As one answer. And y equals -1 as our other answer. Sorry, can't talk now. Okay, and this is how we've solved quadratic equations until now. And as long as we're able to factor, as long as we're able to put our trinomial into two binomials, we can solve that. I'm going to show you an alternate method that doesn't involve this kind of factoring. Usually, when I have a quadratic equation, I go back to regular factoring. But not everything is going to be factorable. So therefore, I need an alternate method. The alternate method that I'm going to show you now, one of them is this completing the square. And we're going to see how it can work in certain cases, even if we can't factor. This one we could factor. I just want to show you that you're going to come out with the same exact answer. So what is this completing the square method? This one. We're starting out with the same y squared plus 6y plus 5 equal to 0. Method is very different. When we have a quadratic equation, until now, we wanted to make sure everything was on one side and equal to 0 on the other side. In this completing the square method, we want only the variables on one side and the regular number that doesn't have a variable, in this case, the y, has to be brought to the other side. So this will give me y squared plus 6y equals -5. Now, if you notice, I left a space. I left the space next to the 6y because what I want to do is that process that I called completing the square. I want to figure out what number I should have add to make this into a perfect square binomial. Well, I know the first number is going to be the y, and the second number in the binomial is going to be half of what's in front of that 6y. So half of 6 is 3. Just like what we did before, we're figuring out what we should add to make this a perfect square binomial. What number should we add to make this the best trinomial? And I know that I have to put the 3 inside the parentheses, and the number that goes over here, just like we did before, is 3 times 3, which is 9. I'm going to have to add 9 in order to make this into the y plus 3 squared. Well, think about it. This is an equation. Whatever you do to one side, you better do the exact same thing to the other side. So therefore, I add 9 to this side as well. How did I decide on the 9? I took half of this number. I knew that's what's going to go into parentheses, multiplied it by itself. I squared that number. 3 times 3 gave me 9. Now look what we have. Over here we have y plus 3, this binomial squared. And here we can combine -5 plus 9, which gives me 4, which is the perfect setup now for the square root method. Remember what we did with the square root method? We took the square root of this side, which is just the y plus 3. And on this side, we did plus or minus the square root of that number, which is 4. Well, that isn't easy. Square root of 4 is just 2. So that I end up with y plus 3 equals plus or minus 2. And now remember what I have to do. I have to bring this 3 to the other side to get y alone, which gives me, I don't want to go too low on this, y equals -3 plus or minus 2. Now, over here, let me go over here to finish that up. We have -3 plus 2 as one answer, -3 minus 2 as my other answer. But these numbers can be, these are like numbers, they're both rational. -3 plus 2 is -1. -3 minus 2 is -5. And guess what I get as my answers? -5 and -1. Exactly the same answer. Which method is easier? I think if you can factor it, the factoring method is easier. But this is a method that will enable us to solve a quadratic equation, even if we can't factor it. Let me show you an example like that. Let's say I gave you this example. Okay, let's take this quadratic equation. X squared minus 4x plus 5. And I'm going to start trying to solve it the way I always solve a quadratic equation, by trying to factor it. I know it's a quadratic equation because it has an x squared. So just watch this because it's not going to work. So I'm going to try and break it up into my 2 parentheses. Well, the x squared, that's easy. It's x and x. And look at the signs. This is plus, means both signs are going to be the same. They're both going to have to be negative. And I'm going to look for 2 numbers that when I multiply them to 5, they add up to 4. You don't subtract to 4, they add to 4. And I don't know any numbers like that. It can't be 5 and 1 because -5 and -1 are -6. And it can't be a plus and a minus because the last term is positive, means both signs have to be the same. So this looked like it would be a relatively simple example, but it's not because I can't factor it. Not every trinomial is factorable. But this new method might work. Now, when do I use this new method? When my original example, the coefficient, the leading coefficient of the x squared is just 1. I don't have any number in front of the x squared. And the number in front of the x is even. If I don't have both of those situations, I don't want to use this method because there's going to be another method we can learn also. Okay, so we're specifically applying this completing the square method when my original x squared is just an x squared. There's nothing in front of it, or a y squared, or whatever the letter is. And the number in front of the x is even. Okay, let's see how we went about solving this using the completing the square. Step number 1, you only want the x's on the left side. Any regular number has to be brought to the other side. So we have x squared minus 4x equals negative 5. Okay. And then, if you remember what I said to do, you want to write this as x something squared. We always put that down. And the number that I'm going to put in the parentheses with the x is always half of this number. So that is going to be minus 2. And the number that we had to add to make this a perfect square, because I really need a third term, would be this number multiplied by itself. It's negative 2 times negative 2, which is plus 4. I have to add 4 to both sides. Remember, whatever I add on this side to make this into a perfect square trinomial, I add the same exact thing on the other side. And again, it's going to be easy to figure out what to add because I'll take half of this number and multiply by itself. Half of negative 2, 4 is 2, negative 2 times negative 2 is positive 4. And here's my binomial squared. And on the other side, I have negative 5 plus 4, which is negative 1. And now that we have the binomial squared, we're going to use our square root method. We're going to just take away that square on the binomial, and on the other side we're going to do plus or minus the square root of this number, negative 1. Well, now we know why we couldn't solve this by factoring, because the square root of negative 1 happens to be I. This is plus or minus I. And I is not a rational number. You can only solve things by factoring if your answers are going to be rational. And all I have to now do is bring the 2 to the other side. Again, remember, I always leave that number in the front. So my x becomes 2 plus or minus I. And you could really write your answer just like that. Or if you wanted, you could separate it and do 2 plus I as one answer and 2 minus I as your other answer. Again, this is sort of more efficient, but sometimes they write the answers like this with that special symbol. Sometimes they write it separate. Notice the answers turn out to be conjugates of each other. 2 plus I is the conjugate of 2 minus I. That always happens when you get I's in your answers. You get conjugate binomials. So here's an example where we couldn't have done this unless we could have completed the square. Let's see what I can find. Yeah. What you would do. Here's an example for you. I'm gonna write it over there so you can still see the method over here. And this is off of final, so therefore I'm gonna give it to you as a multiple choice. Okay, here's the example. X squared minus 2x minus 17 equals 0. And here are your answers. Answer number A, 1 plus 3 radical 2, and 1 minus 3 radical 2. Is answer number 1, A. B is 1 plus or minus 8i. C, plus or minus 3 radical 2. And D, 1 plus square root of 2 as one answer, 1 minus square root of 2 as your other answer. Okay, so if I look at the answers, I don't see any answer that could come just by factoring. So obviously, this is the one I'm going to have to use the completing the square. I'm going to give you a few minutes to try it and see if you come up with an answer. Okay, let's try this together. I'm going to erase this side so that I'll have room to work on that. Okay. Okay, Ariana, I'm giving you credit for that. Let's see if you came up with the right answer. Okay, so what we have here is x squared minus 2x minus 17 equals 0. And we want to use this completing the square method. So the first thing we're going to do is bring the 17 to the other side. So that we end up with x squared minus 2x space equals 17. Okay, we're going to make this into a perfect square binomial. So let's write that over here. It's going to start out with an x, whatever that letter is. If it would be a y, we'd start out y. And the second number is always half of the coefficient of the x. So half, or dividing the -2 by 2, taking half of -2 gives us -1. What's going to have to be in the parentheses with the x is going to have to be a -1, which means that I'm going to have to multiply this by itself, which is +1, add +1 to both sides. When I have x squared minus 2x plus 1, that is the perfect, that in factor form is x minus 1 squared. This is now a perfect square binomial. On the other side, I have 17 plus 1. I could just add them. It gives me 18. And now I'm going to take the square root of both sides, which will give me x minus 1 on this side. And on the other side, it's going to be plus or minus the square root of 18. Now, 18 is not a perfect square. But what we can break it up into is the square root of 9 and the square root of 2. And the square root of 9 happens to be 3. So that I end up with x minus 1 equals plus or minus 3 radical 2. Don't forget that plus or minus. And now we'll add 1 to both sides. So that my answer in the end is x equals 1 plus or minus 3 radical 2, which means 1 plus 3 radical 2 is one answer, and 1 minus 3 radical 2 is the other answer. And yes, you are right, Oriana, it is choice A. Choice A was the correct answer. Don't forget that one. Let's do one more example like this, and then we will start on Wednesday learning another method that we can use, which is called the quadratic formula, which is an extremely important formula for you to know. Okay, but let's do one more like this. suppose I gave you this one, x squared plus 6x equals -3. And I want you to use this completing the square method. Don't forget to look on Delta Math for examples. You should have done quiz 3 on Delta Math, and I'm going to be posting new examples of this sort on Delta Math. Okay, let's work on this together and see if we come up with an answer for this. Again, we see we have a quadratic equation. It's x squared plus 6x equals -3. And actually, it's set up perfectly now for the completing the square method, which I told you I wanted you to use. Let's see if how we solve this. So if we're going to use the completing the square method, we're going to have end up with something, a binomial with a square on the outside. And of course, the first thing is going to be the x. And the second number is going to be half of the number that's in front of the x, the coefficient of the x. So half of 6 is 3. So it's gonna have to be x plus 3. It has to be a plus. You always make sure you're taking the sign as well. Whatever sign this is, that's what goes in your parentheses. Now, what number would we have had to add to make this into this binomial squared? Well, it's always this number squared. It's always this number times itself. 3 times 3. It would have had to be plus 9, which means I have to add 9 to both sides. Which gives me that the x plus 3 squared, which is the factored form of this x squared plus 6x plus 9, is negative 3 plus 9, which is 6. And now we take the square root and we get just x plus 3 on the left side and plus or minus the square root of 6 on the right side. The square root of 6, it's an irrational number, but it can't be simplified because the only thing 6 breaks up into is 2 and 3. Neither of them is a perfect square. But I do have to bring this 3 over to the other side. So my answer becomes x equals negative 3 plus or minus radical 6. And again, you can write your answer this way, or you could write it this way, negative 3 plus radical 6 and radical 3 and negative 3 minus radical 6. So either answer format of the answer, it's the same answer, it's just different formats. Okay, so that's solving a quadratic equation using the completing the square method. It doesn't solve all our problems because if you remember, I told you specifically that you could use in other instances, but then it gets so complicated with fractions. Like if there's a number in front, you have to divide out the whole number. Basically, the only time it really makes sense to use the completing square method is you're starting out with your x squared having no number in front of it. The leading we always say the leading coefficient is 1, and the number in front of the x is even, so that you can easily divide it by 2. All right, I'm going to, unless somebody has a question, I'm going to stop class now. It's a little bit early, but we're going to be continuing with this and solving quadratic equations. We're going to look at another method that will be all-inclusive. Any quadratic equation can be solved using that method. Okay, have a good day.